Hi everyone, this is Ravina. Welcome back to Pseudocoder. Today I'm gonna talk about what is recursion. I have been getting many requests that can you please explain, some data structures, some specific techniques that I use. So today I'm gonna do that. I'm going to go through recursion with you guys, and today we're gonna talk some basics like what is a recursion, how can you use recursion when you solve a particular problem, how to um, manage, how to think, how to implement recursion in the problem. So today we are going to talk about all that. So let's do it. So first of all, what is recursion? Recursion is basically solving small parts of the same problem in order to solve the whole problem. So for example, suppose you have, this big problem. What you can do is you can just divide it into, say, six sub-problems. So these are six sub-problems, and then you solve each of these sub-problems uh, in order to get answer for this whole pie here. So that is what recursion is. Let's try and understand it, with the help of an example. A very popular example we have is factorial. So if you don't know what factorial is, let me give you a small brief explanation. Factorial of a number is basically product of 1 through that number. So suppose if you have 3 factorial, so it will be uh, 3 into 2 into 1. So from 1 to that number. So product of all the elements from 1 to that particular number. So n factorial would be, n into n minus 1 into n minus 2, blah, 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 blah. Okay. So let's see how we can solve this factorial. Why do we say that factorial is one of the popular recursion problems? So let's see. If suppose we have 3 factorial, we want to calculate 3 factorial. 3 factorial is essentially 3 into 2 into 1. Do you know what 2 factorial is? 2 factorial is 2 into 1. If you look at this particular part here, 2 into 1, what is 2 into 1? It's actually 2 factorial. So this particular example can be written as 3 into 2 factorial. So we can just calculate, we can do 3, which is the number that is provided to us, and then calculate 2 factorial of it. And if we keep doing that, so suppose the next step what we can do is we can do 3 into 2 into 1 factorial. Now, we can go one level deep. So we have these two, and whatever the answer comes out of 1 factorial, we can multiply it. We can do one more thing. We can do 3 into 2 into 1 into 0 factorial. And if you guys don't know, 0 factorial is 1. So when you, so we can calculate 0 factorial and then just multiply this whole thing here. So are you seeing the pattern here? We are calculating small problems within the whole problem to, step by step so that we can solve the whole problem. Okay. Let's see what we can do. What I want to do with you guys is first we understand, the recursion. What is the definition of recursion? Let's see how we can solve this in an. Suppose we get an algorithm example, say calculate factorial. How are we going to do this? First, most important thing that we need in order to solve a recursion problem is the termination statement. So the termination point in our example is what helps us if we don't want to go in a loop. So let's see. I want to show you first how do we solve a recursion problem. In our case, in this particular scenario, 0 factorial is our termination case because we don't actually calculate factorial of a negative number. 0 is we calculate factorials of all the positive numbers and 0. So in our case, this will be a termination condition where you reach 0 factorial. That means that you have to stop. and you have to travel back. Now, what do I mean by, travel back or traverse back? Let me show you this with the help of an example. Let's say you receive a request to calculate 3 factorial. Now, I like to, approach these recursive problems. I don't know why, but my teacher taught me this in my first year, and it kind of stuck. It is stuck in my head. So that's how I approach all the recursive problems. Maybe it will help you as well. When you receive a 3 factorial, it's basically a box where we have a 3 factorial. Now, what I want to do is I want to divide it into a small chunk. My small chunk would be 3 into 2 factorial. And when I say 2 factorial, that means that I'll have to again calculate 2 factorial. So it will be another call for 2 factorial. And so this is my 3 factorial, this is my 2 factorial. I get to my 2 factorial. I'm like, okay, it's 2 into 1 factorial, you know. Okay, now I have to calculate 1 factorial again. I'll go one step ahead. This is my 1 factorial box. It's 1 into 0 factorial. I again have to calculate 0 factorial. I'll go deeper. This is my 0 factorial. 0 factorial, we know value for 0 factorial is 1. Since we know that value, this is going to be our termination statement, guys. We are here. There is no more factorial to be calculated. Recursive problems are basically, we define recursive functions that call themselves. So a function that calls itself is basically a recursive function. When you have a factorial function, you'll notice that we will call the factorial function itself inside that function. So this is what that particular box is looking like. We receive 1. We know, okay, there is no more calculation, factorial calculation. We got to return that. This 0 factorial is going to return 1. This 0 factorial is going to get replaced with 1. This is going to get, this particular box is going to get calculated. 1 into 1 is 1. It will return 1. Now 1 factorial is essentially 1. That's what we received from this box. We got 1. Then we calculate 2 into 1 is actually 2. We are going to return 2 to our initial box, and we know that 2 factorial's value is 2. We calculate 3 into 2, 6. 6 is our answer. 3 factorial is essentially 3 into 2, 3 into 2 into 1, so 3 into 2 into 1 is 6, and that's what we got. So this is how recursion works. It's basically a bunch of boxes, and when you call a recursive function, keep in mind that the recursive function is going to get called first, and then that particular statement is going to get returned. Because this recursive function is getting called first, that is why we were able to do this whole flow. We were able to go from 2 factorial to this particular 2 factorial box. We did 2 into 1 factorial, then we drew a 1 factorial box, then we went to a 0 factorial box. And did you notice that when we come back, that's when we know the value of a particular factorial, we replace it, we calculate it, and then we return it. So this is essentially, how you should approach a recursive problem. In our case, this was our termination. This was a terminating statement. Let's see. I have an example of how to calculate a factorial of a number. So I want to show you so that you understand. You do understand the flow now, but I want to show you what the code looks like. It's really, really simple. Let me get here. Okay, yeah. So this is just my lead code playground. This is my factorial function. My factorial function gets an integer, which is n. I first have a terminating condition. My terminating condition is if my n is 0, I know what 0 factorial is. So I'm going to return 1. That's what we did with our box. So we received 0, we returned 1. What is going to be our next step? Our next step would be, multiply that thing that we received in our return function with the current n, and then just return it. So that's it. It's return n into my factorial of n minus 1. So remember how in my first box we did 3 into 2 factorial. That 2 factorial is essentially n minus 1 because we want to calculate the next number. So it's if we receive 3 in as n, it will be 3 into 2. And then 2 will again be given to the factorial function, and the factorial function will again calculate 2. It will give out 1. In the end, it will give out 0. It will be, once it gives out 0, it will call again. It comes here, gets the terminating condition, and then it starts backtracking. Let me see. Let me show you how it runs. I'm calling the factorial function here. I'm passing it a number. This number is 3. Let's try and run this code. You see, factorial of 3 is 6. Let's try for 5 as well. If I give it 5, factorial is 120. 5 into 4 into 3 into 2 into 1 is essentially 120. So this is how you approach a recursive problem. If you are, having a hard time reading the question, you know that you have to use recursion, but you don't know whether what should be my, terminating statement, and what should be this, what should be that. So read the problem carefully. Try to understand, try to come up with a solution. And when you come up with a solution, keep in mind that you have to have a place where you should stop this recursion. If you do not do that, it's gonna go in an infinite loop, and that's how you get time limit exceeded error message. So if you ever get that, you have to know that maybe there is some problem with the termination statement, or maybe, you have to, if you have not added it, you have to add it. So that's all. And then you have to, call your recursive function at the end and do the calculation appropriately. Now, simple problems that I would suggest for you to do is see how you can do factorial. That is what essentially is climbing stairs. And also you can go through some tree problems, breadth first search. You can do depth first search as well. You can also do, pre-order, post-order traversals. So try those, and then try to practice recursion with simple problems, because those are going to help you build your knowledge, so that when you come across some complex problems, oh, this is just a sub part of this big problem. So maybe I know how to work with this one, so I can work with the whole thing. So just do that, and don't be afraid. Recursion is not that difficult. It looks a little, it feels like it's confusing a little bit, but once you get a hang of it, you should be fine. So thank you so much for watching my video. Give it a thumbs up and leave a comment below if you like my videos. And I will be uploading the same video in Hindi if you're looking for an explanation in Hindi. And also, stay tuned for my upcoming videos. I am gonna upload some DSA concepts and also the algorithm problems as well. Thanks. Bye bye.